I'm going to start by talking about some of the application requirements for lithium-ion. And at the high level, all lithium-ion batteries require some form of protective circuitry. That includes lithium polymer pouch cells as well as iron phosphate. They're all slightly different chemistries, but really they need to be treated about the same with slightly different voltage and current limits. The protection circuitry within the pack must monitor all of the parallel cell groups independently. And the purpose behind that is really to see if any one of them is drifting out of line. Implementing that pack protection by pack voltage alone really isn't sufficient to accomplish that, since one cell could be at a very different voltage from the rest without the pack necessarily being without or outside of its typical voltage range. That pack protection circuitry must protect against several conditions, which we'll cover in the next slide. And there are often additional redundant elements that get added by agency regulation. At minimum, those protection circuits must protect against excessive discharge current, excessive charge current, charging above the rated voltage, discharging below the rated voltage, short circuit, and charging outside of its rated temperature limits, both high and low. This protection is usually integrated into the battery assembly, such as shown in the photo on the right there, though sometimes temperature protection gets done externally via a thermistor that's embedded in the battery and used by that external circuitry. These protection circuits are often the last line of defense. Really shouldn't rely on them as the main mechanism to prevent things like regularly discharging to the bottom of its limit. Application side under voltage lockouts are kind of the ideal way to prevent that primary level. And then you have the safety circuit within the battery to prevent any of that from failing and causing the cells to be exposed to a condition that would be worrisome. Now that we've touched a bit on the protective circuitry, we're going to jump into thermal runaway, which is a big part of why we need these protection circuits in the first place. Thermal runaway is one of the largest risks with lithium-ion batteries. It's essentially an uncontrolled increase in temperature that has reached the point where it can no longer be stopped. That can be the result of a few mechanisms of abuse, a few of which are charging outside of the rated temperature ranges, flow charging, charging above the rated voltage, and discharging below the rated voltage. All of these are cases which lead to some form of damage to the cell, which increases the risk of thermal runaway when combined with another form of abnormal use. So some of these forms of damage to the cell are plating of metallic lithium, decomposition of the electrolyte, gas generation, and reduction of the cathode, which also generates oxygen. Once this form of cell damage has been done, any failure that does happen becomes a lot more catastrophic. If lithium metal melts or is plated and then melts, extremely high temperatures and pressures will be generated by the violent chemical reaction. This pressure results in the safety vent operating, expelling the electrolyte. And if the temperatures are high when the cell vents, this electrolyte can also ignite. In the case where the cathode has been reduced, there's oxygen present within this expelled gas, which can help sustain the reaction or fire. The result of this can also be that the cell can splits if the pressure is so high that the vent cannot expel it quickly enough. So this results in the shrapnel in some cases we talked about previously. The primary hazards during thermal runaway are really temperature, smoke, the fire, and the expulsion of those gases and particulates. Temperatures can even be high enough to melt the aluminum and copper within the cells, and that molten metal would be expelled as well. So given how catastrophic those are, we really need that protective circuitry in place to prevent the cells from being exposed to any of these conditions of abuse that would increase that risk. And having covered that, I'll hand it over to Craig. Thanks.
Good morning, everyone. Yeah, just going to talk about some of the safety around shipping and regulations. Before we start, I get asked all the time about Class D fire extinguishers. They are for metal fires. Generally, we're not actually even dealing with metal in this type of chemistry. We have lithium ions. There is, as Mike was saying, an ability to plate lithium in a over voltage kind of scenario, but for the most part, this stuff happens so quickly that the usefulness to have a Class D extinguisher around is very minimal. You're very rarely going to actually be fighting a metal fire. It will quickly burn itself out, and really you're on to the ABC for your general fire type of scenario. Procedures to dispose of hot batteries. Yes. So, the first thing is you really want to be able to monitor that temperature from a safe distance. So if you're seeing something that is excessively hot for an unknown reason, we would prefer that you would be able to look at this from a distance with some sort of non-contact temperature sensing, such as an IR heat gun or even like a thermal imager type camera, which are great to have around if you're using these things a lot. If you don't have that kind of thing around and you can't really look for when that temperature is coming down to kind of ambient or room temperature, your best bet is to segregate that for 24 hours and not approach it. If the cell is cool, you can continue monitoring as it cools down. When you reach ambient temperature, we have essentially spent the reaction, and you're likely good to move these things. So when that occurs, you can remove these cells from the area and start moving through disposing of them in accordance with your waste and recycling protocols. Yeah, so if you do have a leak or a explosion type event, when safe to do so, i.e. when it's cool and down and nothing is really going on in terms of the reaction anymore, you can just move along to disposal methods to render this thing essentially neutralized. So, place it in the plastic bag or tubing. You can often get these, as you can see in the picture there, it's a roll tubing with an impact sealer. Place that in a plastic bag or tubing, fill that completely with baking soda, just pack it with baking soda so that any acid gases can be neutralized. It also works as a desiccant for any other liquids that are coming out of there. Place that in a second plastic bag and then dispose of that battery through normal channels. You can clean the area where you have these. If there's any sort of residue, you can clean that with baking soda and dispose of that. A quiz. So which of the following is likely to cause a secondary lithium cell pack safety incident? Ooh. Well, it looks like you were all had your coffee this morning. Yeah. All of the above, right? We're really looking for scenarios that could create short circuits, et cetera, inside that pack. So charging could also be a problem. Crushing, overcharging, these are all potential issues. So we can't touch on the depth of all the regulations because there's more and more and more of these things coming up. And so I would encourage you all as shippers and receivers and users of these devices to really ensure that you have a program that touches on, for the most part, if most of you are in North America, will touch on these particular items. There's some items that might not be, for example, OSHA in the States and in Canada, it's a little bit different. But for the most part, this is kind of the area you want to have, and you really are obligated to have a program around this stuff. And so it's very important that you get a hold of that and make sure that you're doing all the things internally that are going to make sure that a transport audit isn't going to bring up a big concern for your facility. It's never any fun when the transport regulators show up at your door. But for the most part, for ground type transport, we're generally talking about 49 CFR Part 172, and for air, we're looking at IATA. So you just make sure that you've got your shippers trained. One part of the training is to ensure that you've actually trained around the specific type of dangerous good or regulated good that you actually transport. So this training, and we'll put up a link later for a training cert. This actually can satisfy that particular item around your specific lithium rechargeable product. So under OSHA standards, these types of batteries are actually considered an article. For many years, that actually kind of made them in a gray zone around SDS, safety data sheet type of requirements, but more and more a safety data sheet is just available, or Excell definitely has safety data sheets available to you for that. So just make sure you have that. It's a good thing to have around if an actual event or even a shipping scenario comes up. Accidental release measures. There is a North American Emergency Response Guide, and it's available widely. It's easy to get. Any shipping supply company will generally be able to supply you with this. Even something like Amazon or something, you can get the emergency response guide. So I would encourage you to have that at your facility. It's not an expensive book, so it's just good to have that on site. Right. So shipping the lithium-ion batteries. So all these secondary lithium batteries, they're all regulated as dangerous goods by air and hazmat, hazardous materials by ground. So, you have to make sure that you've undergone the appropriate dangerous goods training for your shippers. The regulations are similar for both ground and air. Mostly it comes down to differences in paperwork. Ground can have slightly lower levels of regulations for similar quantities, but a proper dangerous goods training course will get you in the know on all of the variances. All shippers, once again, of lithium-ion batteries, they must be properly trained. Right? So you don't want to not have a training cert up on your wall when the transport authority comes to take a look at how you've been doing. It's not very difficult. We can certainly point you towards several online ones that are quite good, and you can also get these trainings in person. Basic lithium battery shipping requirements. Medium and large batteries are shipped as class 9, so the full dangerous goods or hazmat kind of paperwork. There's a lot of requirements around the documentation and making sure that you have it right. And once again, it varies from ground to air, from large to small to medium-sized battery packs. So the quantities and all that can actually change. Not change, but it can be different depending on the format that you're trying to ship under. So just make sure that you've taken a course and you're looking at the appropriate regulations for what you specifically are doing. Spec packaging or specification packaging, if it is fully kind of class 9, is required. So you can often identify spec packaging with the UN mark on the side of the boxes. You can see on that box in the right corner there. At the top there, you can see the little UN that says a 4G or 4GB box. It's quite common for shipping these things around. The batteries must be tested to UN 38.3 specifications. So just make sure that when you have a battery pack, you can point towards that. So you may want to ask your battery provider to ensure that you've got a test certificate so that you have that covered if somebody comes to look, to make sure that you have done all that due diligence around ensuring that the battery is safe. Shipper training is required. And a 24-hour emergency number has to be included on the paperwork. That's going away at the beginning of the new year, but it's these things have become so ubiquitous that essentially a understanding number of lithium ion is something that transport carriers understand and responders understand already. Aha. When a secondary lithium cell or battery is ready for disposal, it has to be sent to an appropriate recycling facility. As regulated goods, these are not to show up in the municipal waste. Something that is ready for disposal could be less safe for air transport. So you should certainly not be just sending them air transport. And there's no reason you need to store something for any duration of time before getting it off for recycling. So as part of this, and as I was saying, for understanding how to ship and receive and transport your products, I would recommend that you do scan the QR code here. I'll give you a couple minutes to scan that if you like, so that you can put in a request for your safety certificate. And it functions also as that sort of general understanding of the dangerous goods you're actually trying to ship. So it can go against your requirements to understand what you are handling. You can certainly, if you miss this QR code, you can certainly ask us for it, and please register by this Friday so we can send out these certs. We'll email them to you next week.